Welcome to the scilab. Now we will see some simple numericals in the scilabs. Actually, the scilab it mainly deals with numbers and like matrix and matrices. There's no concept of the strings at now. So, basic numericals. Now we are going to see some basic numerals like addition, subtractions, multiplication. So what to do, how to use all those things. So what are the some special things that are available in the scilab for the basic numericals, those things. So first of all, I'm going to open scilab. I already installed it and I showed how to install. You just need to open scilab 6.1.0 64-bit desktop. Okay, remember this desktop. Then click on this. It will going to open the scilab. It takes some time. Yeah, you can even use the scilab cloud that also I already showed. If you don't have the laptops or any technical error, then you can use that. So here yeah, first of all, some basic numericals that includes addition. For the addition we can just use a plus symbol. For example, yeah, 4 plus 5. If I click the enter, it will going to directly execute it and it will give us the result. Answer equals to 9. Okay. Then for the subtraction we are using the minus symbol, and I think these are all the things familiar with you. And for the multiplication we are using this star mark. Okay, 6 star 5, it will give us 30. And for the division we are going to use divided by symbol, that means like a reverse of the slash. Okay. Then another thing, important thing is, in order to find the powers, that means 2 power 6 or 3 power anything powers. So for that, here we are using the wedge symbol. Remember this. Okay, wedge means it is a shift 6, this symbol. Okay, we are using this wedge symbol. We will check whether it is possible to zoom this window or not. Wait for time. Yeah, I think now it's visible. I just changed the text color and the text of font. And here, go to file and go to not in the file, go to edit and go to preferences. And here you can see this. Here in the font section you'll come to see those monophase, the size and all. Okay, then just click apply. Then it will going to change the font size, and even you can change the font style. Okay, now let's come back to our basic numericals. So for that, that means in order to calculate the powers, we are going to use the wedge symbol. Wedge symbol is this symbol. Okay, that means, for example, 2 to the power 2 to the power 4. Then you can see it will going to 16. This is called as the wedge symbol, 2 to the power 4. So in order to find the power, that is the main thing, because it is a little bit different when we compare to our Python and all. There we are using the star double star operator, but here we are going to use the wedge symbol. Okay, then there are some constants are there. That means they are already predefined. That means for pi and for exponential you have to use percentage e. If I click percentage e, then you can see it is 2.71187182. And for pi we need to use percentage pi. Okay, then you can see 3.1415. These two are the constants, that means already pre-built. So we can just use, instead of 3.1415, we can just use percentage pi for the phi, and for the exponential we need to use percentage e. Then another thing is, it is a case sensitive. Okay, so case sensitive means, instead of pi small letters, if I type pi, then you can see you will get the error, undefined variable percentage pi, because it's a case sensitive. For example, if you want to find square root, sqrt. Okay, these are all some of the inbuilt function I'm using now. For example, sqrt of 4, and if I click the enter, it will going to give us the 2. But instead of sqrt small letters, if I type in capital letter, okay, yes, capital Q, okay, sqrt. If you write like this, then it will going to give us the error. It's because this is case sensitive. That means the alphabets while writing anything, we need to take care of that which case it is, like that. Okay. Then next comes the representation of the complex numbers. In order to represent the complex numbers, we need to use modulus or that percentage. Okay, this symbol percentage and I. Okay, this is used for example, if I have 2 plus 3i, it's a complex notation. So 2 plus and I think yeah, 2 plus 3i. So in order to represent that complex number, we need to just use this percentage, or what we call as the modulus of I. Then if you click the enter, you can see, yeah, what is that? 2 plus 3, syntax error, unexpected identifier expecting end of file. Yeah, I think I given some space. Okay, we'll check it. 2 plus 3i. Why it's giving the syntax error? We will check that. Yeah, this is the basic mistake we do in order to while representing the complex numbers. If we represent simply like this, it will give us the syntax error. So what we have to write means we need to just write 2 plus and 3. Instead of this percentage I, we need to, before that we need to use star. That means we are multiplying this 3 with that complex I. 3i means 3 into I. I is representing in complex form, so percentage I or modulus I. 3 star I, 3 star and modulus I. Okay, that means now we can see 2 plus 3 into I. Okay, now if I click the enter, then you can see 2 plus 3i. It is the complex notation. Remember this. If you just forget this multiplication, then this will give us the error. So this is the form of representing the complex numbers. Then here in all the above examples, you see whatever I'm writing, for example 5 plus 6, when I click the enter, it will directly gives us the answer. So what to do in order to continue the lines, that means in order to continue the program, if you don't want like a line by line execution, then what to do? Then we need to just use the semicolon. For example 3 plus 4, and I'm going to use this semicolon. That means it is not display the result directly. So I will click the enter. Yeah, now 3 plus 4 is done, but it is not displaying. For example C equals to 4 plus 5. We'll check. Yeah, it is 9. It is displaying now because I have not used this semicolon. Now what I'm going to do means D equals to 4. Okay, D equals to 4 plus 5, and now I'm going to use this semicolon. Then if I click the enter, it will already calculated and it will assign the 9 to the D, but it's not displaying. When I just click the enter, then it will going to display D equals to 9. You can see that. Okay, so in order to not display the things at that time, you need to use this semicolon. And we can even see here that this is what the console that we are going to write. Okay, that means these basic things and all. And here this is the variable browser. That means what are all the variables that we used here. For example, here I used D and C, and here before I used, I think, ANS. No, ANS is not, it is the default variable. That means it is going to, here you can see it is the default variable. Whatever the final answer is there, that will be assigned to this ANS variable, and here you can see that ANS, C and D, and it will going to show its value and its type and its whether it's a local or global variables, and even the memory, how much memory it will going to consume. And this is the command history. Whatever the command will giving, that are all stored as history like this, that you can see here. Okay, all the commands that we give previous, that are stored as some history like this. Okay, it is like date wise it will going to save all the commands whatever we are going to write. And here is the new speed. That means if any latest things or comes here, then we can see here. And this is the browser file. Okay, we will check this later what it is and how it will how we can use that and all. And even it provides the lots of inbuilt functions. Okay, for example, if I want to find the factorial, then I can just no need to write any functions or no need to write any lots of lines of codes as in other programs. You can just use like FAC, okay, FACTOR, but I don't know what is the function name. Okay, I may think it is factorial, but I'm not sure at that time. What we can do means you can just type fact, okay, because any function it has the name relevant to it. So I'm going to just type fact and I press the tab button, then it will give us, okay, here you can see factor, factorial, factors. So factorial, yeah, factorial function is there. So I can come to now whether a function is there or not. So factorial, just click enter. It will going to take this as the factorial of 5. Then you can see it will going us to calculate it and it gives us the answer 120. If we don't, there are lots of functions are there. Here you can see when I just type FAC, okay, then when I click the tab, here it will going to give factor, this also the function, factorial and factors, like this. Okay, for example, okay, we will yeah, only one function for the time being. I know there are lots of inbuilt function. We'll check that. Yeah, this sqrt, that's also the function, and we can even use the exponential ex. Okay, we'll just check the tab, example run exec. Okay, what all the functions are there? Here you can see all those things. Exp, okay, it is the exponential scilab function. Here you can see exponential of 3. We'll check, I think, yeah, here you can see e to the power 3, exponential e to the power 3. It will going us to give 20.0855, like this. And even it is not only limited to the software, but also you can use all these things in online scilab cloud. That means here I'm going to just type if you don't have the phone or anything, then you can just that means not phone, if you don't have laptop or anything, then you can just make use of this scilab cloud. Okay, here in any device you can access this. Just type a scilab cloud, and here I'm going to write for example sqrt of 10. Okay, then but here if I click the enter, it will go to the next line. So in order to execute that, you just need to press this execute button. Yeah, here you can get this answer. And even we can do the facto FAC when but here the tab button will not going to work as in software. So we just need to remember, I think, yeah, we just need to remember those things, the commands or the functions. factorial, factorial of 3. I'm going to click execute. 6. And here another thing is that even we cannot able to save all those commands here directly. So it is just writing of the code and executing this, but we can use this. I think yeah, we cannot use that. I think you've understand about the basic numericals of this scilab. Thank you.